Alright, so in the last video we started looking at algebraic ways you can evaluate limits. So we talked about substitution, where you just substitute the x value into the function. So for example, the limit as x approaches 1 of 2x is equal to 2 times 1, which is equal to 2. We also talked about factoring out and simplifying, which you might need to do when you get something like the limit as x approaches 4 of x minus 4 over x squared minus 16. If I plug in 4 here, I would get 4 minus 4 over 4 squared minus 16, which is 0 over 0. This is an indeterminate value. And it doesn't tell you what the limit is. So what you can do instead is you can factor out. So you can factor x squared minus 16 into x plus 4 times x minus 4. Cancel out common terms, and you're left with the limit as x approaches 4 of 1 over x plus 4. Now we can substitute 1 over 4 plus 4 is equal to 1 over 8. Sometimes you'll get functions that have square roots, and one method you can use for those functions is to multiply by the conjugate. Okay, so I'll show you just an example. Let's say you have the limit as x approaches 1 of the square root of x minus 1 over x minus 1. So as you can see, if I plugged in 1 for x, I would get 0 over 0, which is indeterminate. This doesn't tell us anything, so we have to try a different method. So one way you can do this is to multiply this function by its conjugate. The conjugate of a function a minus b is a plus b. So square root of x is the a term, and 1 is the b term, as you guys can see. And we just change the operation in between to the opposite operation. Now we can't just multiply a function by anything and not change it, right? So by multiplying this function by the conjugate, I would change the function. So we have to multiply the numerator and the denominator by the conjugate. That way, we're multiplying by 1. We're not really changing the function, and we can evaluate its limit. So let's multiply this out. So we are left with root x minus 1 times root x plus 1 over x minus 1 times root x plus 1. Now, so as you can see, we have an a minus b and an a plus b. I'm going to show you a little trick whenever you get something that's a minus b times a plus b. Okay, so let's FOIL this up. So a times a is a squared. A times b is ab. Minus b times a is minus ab. And minus b times c is minus b squared. These middle terms cancel out, and you're left with a squared minus b squared. So whenever you have a minus b times a plus b, you're always left with a squared minus b squared. So as you can see right here, we have an a minus b times an a plus b. So I'll really be left with a squared minus b squared. Well, a squared is root x squared, and b squared is 1 squared, and I have a minus in between. And then I'm left with the denominator. I can't simplify the denominator anymore, So I'll just leave it. Okay, then I'm left with root x squared is x, minus 1 squared is 1, all over x minus 1 times root x plus 1. As you can see, I have a common term, x minus 1, on the numerator and in the denominator, so I can cancel them out. And I'm left with 1 over root x plus 1. Now I can substitute. My original limit I was trying to find, so 1 over root 1 plus 1, which is equal to 1 over 1 plus 1, which is equal to 1 over 2. And that is my limit as x approaches 1 of root x minus 1 over x minus 1. Okay? So this is something you can try when you have, like I said, either an a minus b term or an a plus b term. It's usually used though when you have the square root, either your a term or your b term, because then you can get rid of the square root in the middle. Okay, so let me show you another example, just to show you another example. Now you can do this even if the square root is on the denominator. Okay, this is not limited to when your square root is in the numerator. So maybe you could try it with let's see. Maybe we can try with the limit of x not minus x all over x minus 9. So again, if I plug in x equals 9, I would get 3 minus root 9 over 9 minus 9, which is 3 over 3 over 9 minus 9, which is 0 over 0. This is a determinant. It doesn't tell us anything, so we got to try a different method. So again, let's try multiplying by the conjugate. So the limit is x equals 9, 3 minus the square root of x over x minus 9. So we have an a minus b term. So we want to multiply by a plus b, so square root of x. Again, we can't multiply just the numerator because that would change the function. So we have to also multiply the denominator by 3 plus x. We have an a minus b times an a plus b. We get a squared minus b squared, which is 3 squared minus root x squared all over x minus 9 times 3 plus root x. Okay? So now we have 9 minus x over x minus 9 times 3 plus root x. So you may be tempted to cancel out this 9 minus x and this x minus 9, but be careful, they are not the same thing. 9 here is positive and 9 here is negative. X here is negative, whereas x here is positive. So they are not the same thing. So what you can do is you can factor out a negative, which would make this minus 9 plus x over x minus 9 times 3 plus root x. Okay, so all I did was just factor out a negative 1, so I switched the signs of the numerator. That becomes then negative x minus 9. All I did was switch the negative 9 and the positive x. Okay, and over x minus 9 times 3 plus root x. Now I can cancel out this x minus 9 and this x minus 9. I'm left with negative 1 over 3 plus root x. And now hopefully I can plug in my x approaching 9. So I'm left with negative 1 over 3 plus root 9, which is equal to negative 1 over 3 plus 3, which is equal to negative 1 over 6. And that is our limit. So this is something you can try out. Maybe now that you know about multiplying by conjugate, you can try practicing with the limit as x approaches 4 of negative root x plus 2 over x minus 4. And you can try to see if you can find this limit using the method of multiplying by the conjugates. In the next video, we'll discuss even more ways to algebraically evaluate a limit, as well as start talking about asymptotes and how they are related to limits as well.